Hi everyone, I'm Mr. Cheng from St. David High School. Today I'm going to bring you lessons on 7.1.2 Derive the formula for divisor of the line segment in the KSSM plane. It's under the Content Standard 7.1 Divisor of the line segment of Chapter 7 Coordinate Geometry. I would like to divide this lesson into two parts, where in part 1 today I will going to show you how to derive the formula for divisor of the line segment, and for the next coming lessons, part 2 will show you on how to apply the formula in various situations in our daily life. Before we get into the derivation of the formula for divisor of the line segment, let us recap what you have learned in the previous lessons. I think you have been exposed to the concept of divisor of line segment in the previous lessons. So what is a line segment? Line segment is part of a straight line with two endpoints with specific length distance, and any point that divides the segments in a particular ratio on the line segment is known as the internal point. So this is one of the example line segment AB with the position of point P on the line segment as shown here, and this position of point P will divide the line segment in the ratio n to n. So the position of point P actually will determine the n number of equal parts for section AP and n number of equal parts for section PB. If the ratio m to n changes, so the position of the point P will be changed too. Okay? If the value of m is equal to value of n, then the point P will serve as the midpoint of the line segment AB. So in short, as a conclusion, point P on the line segment AB will divide the line segment in the ratio m to n, and we will divide the line segment in two parts. This ratio mn actually reflects that the line segment AB is divided into m plus n equal parts. So this is a line segment, okay, with the internal point P and two endpoints A, B. So this point that divide the line segment into two parts according to a certain ratio. So for example, in the ratio of m to n. This formula that relates the duration of the point in the line segments is called section formula. So section formula is given by this equation. So this section formula tells us about the point that divide the line segment, okay, into two parts with the certain ratio. So now let us see how we can derive the formula for divisor of a line segment. Actually, on this line segment, there are two endpoints and one internal point P. So we build some parallel lines, horizontal line across the point A and P with three vertical parallel lines across the point A, P and B. You will see that two similar triangles form. We can use the concept and the properties of similar triangle here to get our section formula. So here, as you can see here, CD or AG actually equal to x minus x1, while DE or PF is actually given by x2 minus x. So pg will be equal to y minus y1 and df will be y2 minus y. Okay, since AC, PD and DE are parallel, okay, so we can make conclusion that out of the concept of similarity, CD or AG over DE over PF, AG over PF is equivalent to the ratio AP over PB. So the ratio of the two corresponding pair of sides in the similar triangle, for example AG over PF, should be always proportional to the other ratio of the other pairs of sides in the similar triangle AP over PB. So we replace a equivalent expression for CD over DE, x minus x1 over x2 minus x. It should be always equal to m over n. So we simplify by moving the terms denominator n over multiply with x minus x1 and x2 minus x over the other side to multiply with the value n. After expanding and simplify, we will get an equivalent expression for the coordinate x in the coordinate p. So the coordinate x for the point P is given by n x1 plus n times x2 over n plus n. So using the same method, we can get the coordinate y of point P through the similar properties of similar triangle, where we can apply the ratio of the pair of sides PG over PF should be equal to AP over PB. So by replacing the relevant expression for PG and PF in here and do some manipulation and simplification, then we should get a equivalent expression for the coordinate y. So the coordinate y of point P is given by n multiplied with y1 plus m multiplied with y2 over m plus n. So by combining the two expressions that we found here, then we should be able to get a formula for section formula that relates the point, internal point P with the two endpoint AB in this way. So coordinates point P xy is given by x multiplied with x1 plus n m multiplied with x2 over n plus n. As for coordinate y is given by n times y1 plus n times y2 over n plus n. That's how we get the formula. Now let us move on. Okay. Do you ever wonder what would happen if m is equal to n? So when m equal to n, the point P will become the midpoint of the line segment it is told you in the previous few slides, and this midpoint of line segment AB is represented by the letter capital M. So when the value of m is equal to n, okay, we can change the value of n to m. Then you will see that the expression now becomes mx1 plus mx2 over m plus m, my1 plus my2 over m plus n. And when we simplify and factorize, we will get this expression. And finally, after simplification, we will get the formula as this: x1 plus x2 over 2, y1 plus y2 over 2. So this is the midpoint formula that you can use when you get to know that the point that you write is the midpoint of the line segment. So the midpoint of the line segment is the point that divide the segment into two parts of equal length. Okay, so the section formula is a formula that is suitable to determine the location of a point that divide a line segment according to a certain ratio. So this section formula is very useful in the other fields such as physics to find the center of mass of system, equilibrium point, and more. I think that's all for today. See you in the next lessons. Bye.